Guys, I am back. I mean, I was only here like a minute ago, but here we go again. Continuing on our next last question that we did, which was valid number, I'm also gonna keep continuing the hard questions. So this one is longest increasing path in a matrix, lead code 329. So let's read the question together, right? We are given a m and m by n integer matrix, and we have to return the length of the longest common path in the matrix. So from each cell, you can either move in four directions: left, right, up, down. You may not move diagonally or move outside the boundary. Okay, wraparound is not allowed, which is great for us. Wraparounds are generally make the code complex because then we'll need to do the modulo operation. But in any case, here we go. We are given an input string of matrix, which is a m by n matrix, and then we need to give the longest path. Now, the longest increasing path is this for this matrix. I know it's kind of hard to see. That's the beauty of it, right? Like, that's the beauty of this particular format. It's that we don't have images, so we need to make our own image so we can understand the problem, ask questions, and show to our interviewer that we know what we're doing, right? So there we go. This is now an image. Okay, so why is the longest increasing path 1269? What does the increasing path mean? It means that all the numbers should be in a strictly increasing order, no duplicates allowed. Okay, so from 1 I can go up to 8, and that's it. I'm stuck at 8 because 8 doesn't have any bigger number in its up, down, left, right territory. So that's it. That's a path of length 1. I can't go from 1 to 1 because how's that going to work, right? Like, it's a path of length 1. So then I go to this one. Okay, from this one, I can either go up 1, 6, that's path of length 2, or I can go to 2. From 2, I can go to 6. From 6, I can go to 9. Okay, so this is the path of length 4. Path of length, if I had gone to this 6, it could have been this 9, or it could have been this 8, but it would have been a path of length 3. Okay, so yeah, that is pretty much the gist of this question. And as you might have guessed it, we can easily solve this question with a DFS algorithm, right? Because we are continuing to the child. So how do we do this? We can basically go to each of our elements and we can calculate the max path from that element and possibly save it in a map or another matrix for a dynamic programming type solution, which will help us with our time complexities, right? So I'm at 9, I see the path is going to be 1. I'm at 9, the path is 1. I'm at 4, 1, 2, 2 paths. Then I'm at 6, 6, 1. Sorry, 1. There's only one path. I go to the 6, 1, 2, 2 paths. And when I hit the 8, I already have the answer for 8. So when I come to 8, I can't go anywhere, which is fine. I go to 2, the path is going to be 6. I already have the answer for all of the numbers for this, so then I'll just get that. And then for 1, and things like that. All right, so this is going to be a combination of DFS and a BFS. DFS, or like, it's not really a combination of a DFS and a BFS. I'm just going to do a linear scan to access each of these elements, and then within, for that particular element, I would have had a DFS solution. And yes, and then that's how it's going to be. Okay, I know I didn't really explain it properly, but I think it's going to be easier to see in the code, right? Because it's a simple DFS. So let's define our DFS first. I'm given a node. Okay, if node in visited, return all right, how do I do this? Let's define a visited matrix of size matrix, and what do I do here? So for R in matrix, length of matrix would give me the number of rows, and then I'll do for C in range length of the first row, which will give me the columns. Matrix 0. So now this reminds me, if there is no matrix, in that case we return 0, because what's the path in that? Nothing. It's going to be 0. And then let's also define the max path length. At first it's going to be 0. I could have defined it before and then just use this for consistency. All right. Now for each of these values, right? What I want to save is max path length is going to be max of max path length and then the DFS of R and C. Okay, makes sense so far? And then we will just return max path length. Okay, so here RC would go in here, and if RC isn't visited, to be honest, this could be a case sometimes, but not all the times, and I'll mention why that's the case. Okay, so assuming that we have RNC in our visited, all right. Now, in other case, how do we do what we want to do, right? What we need is a stack, first of all. I mean, after this, right? So we need a stack. And then we need a, let's call it DP. Why is that? Because I'm going to use a visited set. Okay. Stack dot append. RNC, and then while stack, node R, node C. You know what? We can also call it INJ for ease. Dot pop, okay? And then we also have directions. Directions are only 4, and they are going to be 0, 1, 1, 0, negative 1, 0, 0, negative 1. Those are all the directions that are allowed: up, down, left, right. Okay, so what do I do with this? For D in directions, new R and new C are going to be plus D of 0 plus D of 1. Okay, now what do we want to see? What's a valid path in our case? It's a valid path if matrix and R and C is bigger than RC. In that case, I will append to stack a new R and RNC. Okay. But if this condition doesn't run, that's fine. We don't want to, we don't really want to process that. And truth be told, we don't need a visited set because we can access this. We can access our DP. Now, max path. Let's count the first one. And we need to have a condition check here. NR should be less than length of matrix and greater than equal to 0, and same thing for NC. But the only thing is here, it's going to be matrix first row's length. Okay. All right. So Now, if this in DP, then max path plus equals DPs and RNC. All right. Otherwise, if it's not there, then the first thing we do is we add it to stack. And we increment the max path by 1. Do we increment it by 1? I don't believe we do. I don't believe we do. Because we can only take 1, right? This is where backtracking is needed. Okay, let's go to the question. Assume I am here at the 6, right? I'm doing the DP. I go here. I have the path length. And then I go here. I don't have the path length. I calculate it. So once the calculation is done, okay, let's pass it for argument's sake. So stack.append is going to be here. This is a hard question, I realize. The key for hard questions is like the theory is easy. I know how to do it, but like actually coding it up, it's quite a lot of code and it's confusing me. Right? And I think it goes back to like foundations as well. Okay, so again, assuming I'm here, or let's say here, I processed this DFS. DFS, the stack would be empty. Um, path length. Path length equals 1. I'm here. I've added this to stack. I did a stack.pop. I checked the directions. Nothing fills this. In that case, my like this will just end. Like here, it will end, right? So what do I do with my max path? I put my max path in the DP. DPIJ is my max path, which is just 1 in this case. Okay, then I go here. Again, the same thing, max path is set as 1. IJ is not there. I check for the stack. I append this to the stack. Here you gotta return it. Return the max path. Okay, so again, this path is just 1 here. Then I go to 4. Now for 4, the first direction, I do the whole thing. My first direction is 0, 1. 0, 1. I can't go to 0, 1. So then I go to this one, right? Now here, I already have this value somewhere. So if this is in DP, then my path length would just be max of path length plus TP and end of max path itself. Right, in this case, max path was 1 previously. Okay, this shouldn't be 1 here. Should be defined somewhere outside. Oh. Okay, in any case, so the max is going to be of max path, path length plus TP, right? But otherwise, it's just going to be, okay, let's just do path length here. Path length is going to be this. Otherwise, I have appended 1 column to it, so it's going to be 1. Okay. So anyway, I was here at 4, right? I see when I hit this particular thing, it's already in the DP. So whatever the path length is at this point, which is just 1, I'm going to add my DP to it, right? And that's it. I no longer put this in my stack. Okay. And then stack, the next value in stack is this. So I don't put the new thing in the stack. And okay, so the next thing is 8. 8 is no longer, it was never in the stack earlier. So what do? I add that into the stack, and my path length increases by 1. Okay. Um, okay. Then I go here. 6. Only option is this. This 6 is only option is this. I'll just get it from there. And then this 8. Okay. So the thing is, I should have, because I processed 8 here. Okay, I came to 8, right? Um, did I ever put 8 in DP? This is backtracking. A fucking backtracking. It always confuses me. The only issue right now is that I don't know how to keep the path length updated. Um, and it is extremely confusing to me. Okay, imagine when I had 8 here. RC was for 8. And when okay, I'm cutting the live stream because I honestly don't know how to solve it. There's a minor issue, and I'm quitting this question. Oh, okay, fine. I'm gonna chat GPT it. All right, and I checked it. Um, it was a very simple solution. Okay, so this is correct. This is correct. Okay, so what do we want to do now? Not gonna lie, I'm still extremely confused. So what I'm doing is I'm no longer doing iterative DFS. Like this is a nightmare. Now I'm gonna be doing a recursive DFS. Okay. So let's see if we can do that. If I and j in dp, just return that. I and j. Otherwise, um, we gotta check if I is less than a length of matrix. Same thing for j. And matrix of ij is less than matrix of nj ij. In this case, max path and 1 plus DFS of nj. And I and j. And is going to be max path And then obviously you return max path. Uh, okay, I think this should work. All right, let's do this particular example. Um, okay, so starting from 3, I go into it. There's nothing in db, so max path is 1, and I calculate the directions, and then this happens, and then I calculate the max path of um, this one, right? So whatever is the max path of 5, 6. So I should be able to calculate it. Okay, I'm gonna try running it because why not? Well, I know why not, but like, not really having the best time over here. Um, well, okay, I'm sorry. I just realized I'm talking really, really slow, so I don't know if you guys can hear me. But I am going to lead code now to run it. So let's do it together because I'm too scared to do it alone. Okay, so max path length, metrics, return max path length, TP directions, DFS IJ. And then I'm updating DFS for every time. And yeah, let's do it. For C in range. Equals I plus J equals J plus. Okay, it worked. Not my finest work. But also it is what it is.